Hello there, this is Mr. Frazier, and we are in geometry and in the process of doing a lesson 11.4. Okay, and 11.4 is finding volume. Okay, 11.4 is volume of prisms and cylinders. Now the volume formula is much easier than the surface area formula. Okay, so the volume formula is area of the base times the height of the figure. Now the reason why they put area of the base is because your base can change. Now this formula is actually for both shapes, for cylinders and prisms. What makes the difference? Well, in a cylinder, the base is what shape? A circle, correct. So they give you a different formula with the pi r squared already in it, but in essence, it's the area of the base times the height. It just happens to be that the base we're talking about is a circle. So you understand that all of these problems are still done the same way. Now, I've been teaching you for a while that if you can draw the shape of the base first, then write the area formula, and everything will work fine. So, let's look at a sample problem from the book, or a problem from the book. And I'll use the square prism they do right away. Okay, so problem 1, the sample problem on 752. If you're sitting there, you look at the got it. That's what I'm going to work on. And it says, find the volume of the rectangular prism to the right. So, I first draw my base. And I see my base is a rectangle. And the measurements I put on it are 5 and 3. 5 and 3. This is a rectangle. So I know the area of the base is base times height, which is from here, times the height of the figure. Okay, that's what volume is. So we have 3 times 5. And remember, this height here comes from the numbers I didn't put down. 4. Okay, pretty basic. Not a hard type of problem to do. Where does it get difficult? When the base is not a traditional shape, and you have to find the height, or find the apothem, and you have to do right triangle work. So, let's skip to one of those. We'll look at problem number 2, which happens to be a triangular prism. Alright, so we look at the sample problem they give us. And if I draw the shape of the base, remember the shape of the base is any other shape other than a rectangle, correct, or square. Unless all the sides are rectangle or square. So this is a triangular prism. So I draw the shape of the base, and I put the measurements on that base that they give me as 8, 8, and 8. That's what the base looks like. And I know that volume is area of the base times height. In this case, the base is 1/2 base times height. And then height of the figure. Now, I have the base. It's 8. I don't have a height. Now, how do I know I don't have a height? Well, I don't have a height for this base because there's no right angle mark. If there was a right angle mark, the right angle mark connects or touches the numbers I need to use for the base and the number I need to use for the height. So, I know I'm going to be doing right triangle work. Now, the other height over here is the height of the figure. That's the only number that I didn't use. Hopefully you know that number is now 10. Okay, so I have that number. I have 1/2. I have 8. And I have to do right triangle work to find this other measurement. Okay, so here's my right triangle. When I draw my right triangle, I know that this is always the altitude, or the height. Okay? And this piece over here would have been the apothem. or it can be half the side, depending. In this case, it's going to be half the side. This is always the hypotenuse. The hypotenuse is also always the radius. So, or the side of the triangle. So this one is 8. Now, I know that this is a 30, 60, 90 degree triangle because this has all equal sides, so all the angles are equal. That means all of these were 60. And when I drew that imaginary line there, and I actually drew a right triangle, that means this was 30. This is 60. This would be 30, 60, 90 degree triangle work, which means I go down and divide by 2, because that's the hypotenuse. And when I go up, I multiply by the square root of 3. So I know the hypotenuse, or I know the height is now 4 square root of 3. Now I have the problem done. I put the work in the calculator. It's important that you start the problem the same way because your surface area and your volume problems, a lot of times they'll ask you for the surface area. And if you're doing the same thing over and over again, you just have to make sure you use volume when they want volume and surface area when they want surface area. Alright? Okay, so now we move on to a cylinder. And the only difference is that in a cylinder, the base is a circle, correct? So we're looking at problem 3, and we want to find the volume of that cylinder. So I draw the shape of the base, and in this case, the shape of that base is a circle. So I go ahead and I draw my circle, and I tell you to always put in a radius. So volume is area of the base times height, and in this type, it's pi r squared times h. Okay? So I need the radius. And they give it to us. It's 3. Sometimes they'll give you the diameter, and you'll have to cut it in half. But it's much easier to just always use the radius. Alright. And then the height of the shape would be any other number I didn't put on my circle, which would be 8. Right? So now I have 8. I have 3 squared and pi. When I do this, hopefully you know that this becomes 9. 9 times 8 is 72. The answer is 72 pi. And the only time I change it to a decimal is if they say round your answer to the nearest tenth. Otherwise, you want to keep your answer always in pi. Now, these have a tendency of being much easier than our other problems. Where it becomes tricky is where they use composite figures, or more than one. So that means you might have to do prism work and half of a triangle, or prism work or half of a cylinder, and add those two together. If you see 2 different shapes, or 2 different shapes of bases, you're going to do 2 different problems and then use those pieces to add together. Okay, and you can see that in problem 4, they put right below. You see they have a rectangular prism and then a semicircle. So you'd find the area of the circle, cut it in half, or excuse me, the volume of the cylinder, cut it in half, find the volume of the rectangular prism, use the whole thing, and then add those 2 answers together. Okay. So the work is not difficult, it's just more time consuming. So I'll do the got it problem. Go ahead and pause it. Or excuse me, you go ahead and do the composite, got it, pause it, and then come back and look at my video and see how you did. Okay, so go ahead and pause it and try the sample problem, the got it, which is got it number 4 on page 754. All right. Okay, well, welcome back. So hopefully you know we're doing the got it. So I know I have a lunchbox, and I can see on the lunchbox we're going to have a circle, or semicircle, half of a circle, and we're going to have a rectangular prism. So I draw the shape of the rectangle, and then I do the cylinder. And I know I'm only going to use half the cylinder, but I draw the cylinder anyway. So I know that they give me the radius of the cylinder is 3. And then they give me the base. This is 10 and 6. Okay, so volume. Area of the base times height. Volume. Area of the base times height. Now, remember, I didn't put the big B, I just put the circle. This one is base times height, so it would be BH. Now, those two H's are not the same, but in this picture, they happen to be. Because there's a 10 and a 6, the other number they don't use happens to be a 6. Okay? So I put 10 times 6 times 6. I'm going to get that answer, and it will add to half of this. So I do pi r squared, pi, the radius is 3 squared, and the height. Now this is the tricky part. The height of the cylinder is 10 because it's laying on its side. Okay, the height of the cylinder is 10. From semicircle to semicircle is 10. Okay, if you want to think of it that way, then that would be good. And then I'm going to need half of that. Now this isn't the formula, this is the logic and reasoning you have to do. Why am I only using half of it? Because you can see the lid is a semicircle. So, I have this problem over here, which is 360, plus this volume over here, which is 9 times 10, which is 90, divided by 2, which is 45 pi. And there's your answer. In terms of pi, you just leave it like that. If they ask you to round to the nearest tenth, you put it in your calculator, hit enter, and round to the nearest tenth. Alright, well that is 10-4. 10-5 is pyramids and cones. And we'll deal with that tomorrow. Have a good day.